Example, evaluate the integral of x minus 2 over x squared minus 4x plus 5 dx. Whenever you encounter an integral of a function that you can't directly find an antiderivative for, your next attempt should be to look for a substitution to simplify the integral. In order for substitution to work, we need to find a function in the integrand whose derivative is a factor of the integrand. For rational functions like this one, the denominator is a good place to start. If I let u equal x squared minus 4x plus 5, then du dx, the derivative of u, is 2x minus 4. So du equals 2x minus 4 dx. I don't have exactly 2x minus 4 in the integral, but I do have a constant multiple of it. X minus 2 is exactly half of 2x minus 4. So x minus 2 dx equals 1/2 du. Making this substitution, I replace the x minus 2 and the dx with 1/2 du, and the denominator x squared minus 4x plus 5 with u. My new integral is the integral of 1/2 du over u. I can factor the 1/2 out of the integral, leaving just a du over u. The antiderivative of 1 over u is the natural log of the absolute value of u plus an arbitrary constant c. I can now distribute the 1/2 through to get 1/2 natural log of the absolute value of u plus 1/2 c. Now this is really subtle, but because c is an arbitrary constant, 1/2 c is also an arbitrary constant. So I can actually just let the c absorb the 1/2 and write 1/2 natural log absolute value of u plus c. Finally, u is just a variable I made up to simplify the integral, so I need to switch back to the original variable x. Since my substitution was u equals x squared minus 4x plus 5, I plug that back in for u inside my antiderivative to get my final answer of 1/2 natural log of the absolute value of x squared minus 4x plus 5 plus c.